Yes.
Welcome, everybody. It's Alan Morrison with another episode of the GraphRag Curator podcast. And today I've got a special guest, Frédéric Verhelst of Total Energies. And he's somebody who's got decades of background in digital transformation, including digital twins. He's knowledgeable about hybrid kinds of AI with really some touch points in ontologies, etc. And you can see his whole portfolio at frédéricverhelst.com, and he also blogs on LinkedIn. So, Frédéric, welcome today.
Thank you.
Tell us about your background and how you got to where you are.
Okay. First, a small correction. I'm no longer with Total Energies. I'm now with Viking Life-Saving Equipment. If you see on the back here, we are one of the main players in the world on life rafts and lifeboats and safety equipment in the maritime sector. So, and based in Esbjerg, Denmark. My background, I'm Belgian, and I have an engineering degree first, and then afterwards I took a PhD in applied physics, geophysics, exploration of oil and gas, and that's how I rolled into the oil and gas industry. I've been working with contractors, with small startups, working on technologies, worked with Total Energies, worked closely to Shell, to Chevron, and so on. So I've quite a broad range of experiences and background.
So let's perhaps we could hear a brief history of where the energy industry has been in terms of its data journey and where you think it's headed today. You've been in transformation initiatives over the years. How are those differing from the kinds of initiatives that we're seeing today?
So for me, there are a few key points to start with. Beginning of the 2000s, the Society of Petroleum Engineers, an international association for the oil and gas industry, they started with forums, where the idea is to think 6 to 10 years ahead and to get different viewpoints and perspectives into the mix. In 2003, they had a first one on what I call digital energy, where it was called Smart Fields, and it was actually a start of a series of those type of events. In 2008, there was another event in Dubrovnik, I think it was, where we were talking about petabytes of data for asset management. So that's also gives you an idea of what volumes of data there are in the oil and gas industry. Geophysics especially is we are dealing with terabytes of data. But on the other side, there is another key point, I think, and there was a pretty small oil and gas field offshore Norway with Norsk Hydro at the time, now a part of Equinor, where they, in 2005, 2006, were seeing that the field or the platform as it was operating at that time would not be viable anymore in 2008. So they needed to do something very drastically, and what they did, using the fiber cable that was available, look at all the tasks that needed to be done, that were done offshore, and then see if those could be done onshore. So try to move as many tasks from offshore to onshore using the fiber cable. And in that way, they reduced from a normal manning of 41 persons to a normal manning of 21. And that made that the economic cutoff was shifted so much that now 20 years later, the Braga field is still producing and still generating money. So that's for me one of the first, for me, and perhaps there are others, but what I know, the first example of where digital technology, data, is helping is really making a big impact on the viability and the profitability of a field. And then actually those learnings were used when Statoil and Norsk Hydro merged into Equinor in the end. And they have used that as a footprint where they've put, now they have a 100 people integrated operations center of supporting all their fields across the world, and many are in Norway because it's very much Norway dominated. And they have established that it's really earning them billions per year in US dollars. It's really a good case. Then, yeah.
So talk about the challenges that oil and gas companies face in an exploration mode. You've got this huge amount of data that is desirable to collect and analyze. Then out at the sites, you have a limited bandwidth and all the constraints on resources when you're monitoring existing exploration and drilling efforts. Can you sort of paint the picture of the challenges that you've been involved with trying to address?
So actually the exploration game is very challenging in the way that there is a huge amount of uncertainty. You're actually probing the subsurface using seismic waves with a limited bandwidth, with all kinds of hypotheses when you want to analyze those and to interpret. At the same time, that will lead to decisions of shall we drill or not, where a well typically, or exploration wells can go up to $1 million per well. So the whole uncertainty and the whole making sure that you take all the data that is available, you use analogs from other fields, you use old information you have somewhere lying around, all that information and all those needs to be collected and needs to be interpreted in a good way. And that's where there is data management, especially in the oil and gas industry, originates from the exploration part, from the subsurface part. There they had a real need of having that, and they knew what the consequences would be of a dry well of 100 million or and so on. And then if you go further, then it's once you go for a development, building a platform and so on, then you're talking about 10 billions typically of value, where also uncertainty is still a big part of it. So
Yeah.
So that's actually the game in the exploration part. On the other side, for the drilling part, there was actually one of the a lot of effort was put in the beginning of the 2000s in getting real-time data from drilling rigs to centers on shore, where people could analyze and could assist, making sure that a drill bit is not stuck in the well, because that's costing typically $100,000 per day, $200,000 per day, depending on what type of well. So that where data standards were important, where making sure that the stream of data is continuous, where they were having real-time data centers that were just there to make sure that the data was flowing 24/7. All those aspects.
Can you compare and contrast the structured data that seems to be prominent in the industry, and then also the need for knowledge management and less structured information and bringing those together?
Yes. In exploration, there is a lot of unstructured data available as well. A lot of reports that is available. Actually, what you were seeing, I saw a trend 10 years ago that everything was dumped in a data lake. And then because we must centralize to create value. But oftentimes people were talking about a data lake as a data swamp without structure. Everything is there, but you just need to find the needle in the haystack, and that's one of the issues there. What we did in the Danish affiliate where I was heading the data office, there we had a semantic layer and a virtualization layer that was connected to all the sources of data, so the repositories and so on, and we were putting them in one big data model, or actually contextualizing them in one model, and then exposing that as a semantic layer to the end users or to other software that needed them. So for example, and we had 10 different data domains in that layer. So for example, the concept of a well, or a typical well was in the production database, so structured. It was in drilling reports, so unstructured. It was in reservoir models, so in proprietary databases. It was in regulatory filings. So then the semantic layer made sure that if you called for a well and all the information regarding it, you would get everything you needed. And there was also one truth out of that. So it was also connected to the BI systems that then were running on top of that.
Does graph technology and semantic metadata help with the integration effort in that case? Are you finding use cases for graph databases in addition to the standard relational databases and document databases, etc.?
So I think the best example is a digital twin we have. Mm-hmm. A digital twin is actually, there are different degrees of digital twin, and it's always difficult talking to people what kind of digital twin you're talking about. But you have kind of a first generation of digital twin where you visualize mostly with pictures or with so you have a 3D sense, but it's generated by pictures or by point clouds, so laser scanning, and where you get as built information. And then you have a generation 2 where you also integrate real-time data. Then there is a generation 3, and I think that's where you're talking about, is where you actually make sure that you have that into a semantic model where you can start reasoning about or have reasoning engines on top of your digital twin. So these exist, but they're kind of in parallel, because depending on which organization you have, generation 1 or 2, and I think generation 3 is kind of emerging. But I think with the current focus on generative AI, I think that will be more and more, and people will see the benefit of that more and more. Our digital twin is using the CFOS standard, and CFOS is now also being semantalized. So there is an effort going on there. There is a similar effort for the subsurface, and that's called OSDU, where it's a kind of a data platform and a knowledge capture system for subsurface and exploration domain, and it will be a base for engines on top of it. So being able to build multiple digital twins on top of it, that will then be able to use the semantic foundation by OSDU.
So let's unpack this evolution of the digital twins and where they have been and where they need to be. It would seem like it's rather important, if you've got a digital twin capability and you're able to simulate and model and predict failure, but also just articulate the whole environment that you're working in. It's a situation where meaningful information can really allow AI to do more and do it more accurately. Is leadership behind the whole foundation that needs to be in place to create these interactive digital twins?
A good question. And I'm in an affiliate. I'm not in the head office. Or I was in an affiliate and not in the head office. So I know that I think it's differing, or it depends. There are some leaders that have a vision and that understand why things need to happen. Having said that, in a company like Total Energies, the affiliates here around the North Sea have a different maturity than some other places within the group, where what we think is insufficient as a tool might be a very high step upward for other affiliates. So that's also a part of the consideration to be made, is that as a group, and if you have a kind of a centralized approach to digital twins, then you might get a digital twin that is not completely that needs to cater for all the different countries you're operating in.
Yeah.
But I clearly see in the generations we went, or if I look at Total Energies internally, some affiliates were really looking at unstructured data, and they were happy that they could bring those documents into a kind of a context in a visually appealing system, where they could click from the one. So we use functional locations as the key points. So pumps and pieces of kit on the platform, and then you have PNIDs, so that are kind of drawings that have been hyperlinked, so you can go on the drawing and go upstream, downstream, and find the relevant pieces of kit there. And then having the opportunity to visualize the data sheets connected to that, with all the settings, with all the parameters. That is for some already a very big step forward. For others, you really want to have the data from the data sheets, not the data. So make it into a structured database. So then you're talking about an SQL type of solution. And then the next step is you go to a graph database, where you really implement those connections, and to have those explicit in your system. And then the next step is to go to a knowledge graph and to an ontology on top of that. So that's actually where you see the maturity from going from descriptive to diagnostic, predictive, and prescriptive. And I think that's the journey you need to consider for digital twins. The digital program, there were some leaders in the digital program that had that vision very clearly, and that really were going that way. But things take time. There is a moment, and there is you need to build up that momentum. You need to make good cases, and then things go there. Now, Total Energies also has a CEO who is an engineer, and I know that some other oil and gas companies don't have an engineer at the top. I think that helps. He is somebody who really understands what this can do, and is really a driver for some of those more difficult technologies.
It's really important to have active leadership promoting the right methods, and there's so many competing methods, and I've got a bias toward emerging tech that isn't as well adopted, and the fact that the install base of software gets in the way is often frustrating wherever I'm working. Could you compare the energy industry to other industries in terms of its maturity? You've worked on maturity assessments. You're familiar with the relative maturity of the industry.
Yes, I see similarities with other industries. Especially, one that strikes me a lot on the data side. One that strikes is the pharma. I think they have kind of they need to connect data from many different sources, structured, unstructured, and they also have that aspect of a very strong imprint of the uncertainty. So every decision in the oil and gas we make has a big consequence, or some of the key decisions, I have a very big consequence. And I think I see the same in pharma. Of course, it's a completely different industry, but if you look at how decisions are made and on the basis of what, I think there are similarities. And what I see them doing, of course, it's from the outside. I have the impression that semantic technologies are much more embedded in their way of working than they are in the oil and gas industry. Oil and gas industry, I don't think it has changed, but back in 2000, it was considered as very conservative. And I don't think things have changed a lot. Also, if you look at if we go back to the Braga field that I started with, if it would not have been in 2 years you're fired, or we're gonna close down, or perhaps they would not have been fired, but in 2 years we have to close down. If that sense of urgency was not there, perhaps nothing would have happened. So
Yeah.
so that's yeah.
So talk about the industry you're in now and how that differs, and what the pros and cons of it are from your perspective.
This is a much more low margin company, and it has pros and cons. I think one of the pros is actually if you come up with a very good idea that can make a substantial can have a substantial effect. I think it would be easier to get that through here than it would be in an oil and gas company, but that needs to be seen. We so I'm now working on the digitalization of customer and field services, and yes, that's actually one of a big part of the efficiency of field technicians is a big impact on this, or has a high focus. Use them more efficient, plan everything better. So that's a completely different setting.
Yeah, and the modeling challenge is different. You've got the customer side, much more visible, I would suppose, and immediately relevant in daily operations. And so the understanding humans and their needs and modeling that, and then the supply side as well, you're seeing that come together. Any observations in that kind of circumstance?
I'm not completely sure I understand the question.
So let's say in terms of customer data versus the production side and the manufacturing side of things and distribution, you've got all of those different pieces that have to be brought together. And are you using the same techniques you were using in oil and gas in this context? Where does it stand?
Not yet. We're also we're using Dynamics 365 by Microsoft, and now Microsoft has announced that they will make labeled property graphs available in their system. So it is one thing we are looking at, how to use that. It's not a knowledge graph. It's a knowledge graph, but it's not a semantic or an ontology. But it's a step forward.
Yeah. Yeah. And do they have the resources to take the initiative here? And are they spending a lot? I mean, companies are talking about AI budgets and feel like they're under pressure to adopt these statistically based AI. Then there's all the knowledge representation that has to go on to really make this accurate. Are all those pieces on the table for companies like this one? Are they really thinking about this in a way that you believe is going to be beneficial?
You hear managers asking for AI agents because they hear about it, they read about it, they think it will be a golden solution, or it will help them a lot. I don't think all managers understand the consequences and understand what they actually get into. I've just wrote a post this morning regarding that agentic AI should be seen as not as an employee, but actually as a contractor. There need to be a very specific scope of work. There needs to be guardrails in place, escalation triggers. You need to have monitoring in place, and so on. And you also need to make sure that all those things that you put in place need to be so formalized that it is that a machine can understand it and can stick to it. And that's where the ontology comes in. The ontology needs to be 100% precise, that a key client, or whatever you call it, is defined 100% clear. Otherwise, you will get into surprises.
Unintended consequences, they call them.
Yes, and Air Canada was one of the first who was confronted with some of those consequences. But I'm sure, and I know that some of the consultancy firms also have had some issues with, and lawyers have had issues with made up cases in documents. So it is something you need to be very, very careful about. And the problem with generative AI is it looks damn so convincing.
Mm-hmm.
It is just bullshitting you without a blink.
Yeah.
And it's not bullshitting. It is making things up, but it's doing it in such a way that it really is so convincing.
Yeah. Yeah. So let's think to 2026 and beyond, and where do you think things should be headed in terms of the companies you've been working with? What would be the most beneficial thing they could do starting in 2026?
I think they should start thinking or planning or setting up a team that collects knowledge and that formalizes that into a knowledge graph slash ontology or with an ontology. And I think there is a lot of information that is out there. I think if you talk to your data architects, your data engineers, but for tables, SQL tables, and so on, there is actually a lot of modeling that can be reused and can be formalized in a way that that can give you already a good step forward. I also think that there is a lot of business process data that can be used. There is a lot of in the oil and gas, the description of our facilities offshore can be used. There are lots of different places and pieces of information. You can perhaps look at the skills for the different roles and the people you have in those roles. You could gather a lot of different information in there that will actually be 1 + 1 will be much more than 2, because it will it will make it possible to do things that were not possible before, like agentic AI, for instance. And of course, it needs to be phased that you start with something small that already has a benefit, and then continue from there. But I think that should be something that is also high enough in the organization that they can go across, and they have a mandate of bringing everything together.
Makes complete sense.
Yeah, to you and me, but perhaps for others not.
No, that's the challenge. That's probably the biggest challenge is building alliances across the organization so this can happen. That's really a huge challenge. Well, Frédéric Verhelst, thank you so much for taking the time today. Very illuminating perspective.